isotopes, of these elements that you're calling isotopes, are elements that it is an element that has different versions. So for example, you have chlorine. Chlorine can exist, or it exists in different versions. So you have chlorine 35 and you have chlorine 37. So these isotopes, you're calling them by the number of the mass number that they have. So why do they have the different masses? This is because they only have the same number of protons but the different number of neutrons. So we said for you to get this mass number, you need to add protons and neutrons in your atom. Now, when you talk about isotopes, you talk about the relative atomic mass of an isotope. You're told to calculate the relative atomic mass of an isotope. And how do you do this? The relative atomic mass, or R.A.M, is given by, you take the mass number of your first isotope, you multiply by the relative abundance of your isotope, which you're normally given in a question, okay? And then you do the mass number, you take this first equation, you work it out. So this one, okay? You take the mass number. For example, for chlorine here, you're going to take the mass number of our first isotope. So we are calculating the R.A.M of chlorine in this equation. So we are going to take 35, which is the mass number of the first isotope, okay? You multiply by the percentage abundance, and we say this abundance you're normally given in a question. In this case, the percentage abundance of chlorine 35 is going to be 75%. So it is 35, you multiply by 75%, okay? Now you multiply by 75. Okay. You add the mass number of the second isotope multiplied by its abundance. So the mass number of the second isotope is 37 and its abundance is 25. Again, we've said the relative abundance is normally given when you're working this out. And then you divide by 100. So we are dividing by 100. Sorry, we are dividing by 100 because the abundances are normally given in percentage. So this is how you work it out. And when you do it, so this is our R.A.M. So this is chlorine, the relative atomic mass of chlorine, which is going to be 35.5 in this case, okay? So that is how you calculate the relative atomic mass of an isotope. And in summary, we have said an isotope is the different versions of the same element. Different versions of the same element, and this affects the atomic, this affects the mass number because you have the same atomic number or the same number of protons but different number of neutrons.